Bioperk, exploring life one marvel at a time.
Unified field theory solved, the International Space Federation, ISF. Foster Gamble, a researcher and theorist in unified physics, globally renowned for the documentaries Thrive, What on Earth Will It Take, 2011, Thrive 2, This Is What It Takes, 2020, and The Song That Calls You Home, 2020, discusses the latest remarkable paper by physicists Nassim Haramein, Dr. Olivier Alirol, and Dr. Cyprien Guermont-Prez. Introduction to Unified Field Theory. Unified field theory in physics is a theoretical framework that seeks to explain the fundamental forces of nature within a single, overarching mathematical model. The goal is to unify the four fundamental forces of the standard model of particle physics into a single, coherent framework. In classical physics, the four fundamental forces are categorized as gravity, described by Albert Einstein's general theory of relativity. Electromagnetism, described by Maxwell's classical electromagnetism and quantum electrodynamics, QED. Weak nuclear force, responsible for processes like beta decay and described by electroweak theory. Strong nuclear force, invented ad hoc and detailed in a theory called quantum chromodynamics, QCD, which regards the behavior of so-called quarks and gluons within atomic nuclei. Each of these forces has its own mathematical formulation and set of principles, and they are successful in describing various phenomena within their respective domains. However, it should be possible to unify the formulation of these forces into a single mathematical framework, even a single equation from which the behavior of an object interacting with any of the four forces can be described. What's more, there are compelling reasons, both theoretical and empirical, to believe that these seemingly disparate forces are in fact different facets of a single force. Strong nuclear force, invented ad hoc and detailed in a theory called quantum chromodynamics, QCD, which regards the behavior of so-called quarks and gluons within atomic nuclei. For example, electricity and magnetism were once thought to be separate forces, but we know now that they are a single force, electromagnetism. The so-called weak nuclear force was similarly shown to be a form of electromagnetic interaction, and both are now referred to under the singular title, the electroweak force, and it is posited that at high unification energy, the so-called strong force merges with the electroweak force, resulting in one electronuclear interaction. It is known that all forces apart from gravitation are related mathematically, albeit with some differences in phenomena. So it is logical to contend that this trend will continue, and we will discover that there is a unification of all forces, often referred to as a theory of everything, that will encompass a unified field theory. The most well-known attempt at a unified field theory was Einstein's efforts to combine gravity and electromagnetism. However, his labor was not successful, and even with contemporary attempts like supersymmetry and string theory, no widely accepted unified field theory has been established to date. This, however, may be about to change, as the paper, The Origin of Mass and the Nature of Gravity, available to download for free on the CERN preprint server Zenodo, by Haramein, Guermont-Prez, and Alirol, elucidates the unified physical mechanism, Planck plasma flow, that describes how the strong force and gravity are unified and emerge from the correlation functions of quantum electromagnetic vacuum energy density. Although quantum electromagnetic vacuum fluctuations might sound complex and like a recent discovery, it is the result of the discoveries made by the father of quantum mechanics over 100 years ago, Max Planck, who demonstrated that the electromagnetic field of an oscillator has an infinite amount of energy when cooled down to absolute zero. He coined this discovery zero-point energy, ZPE. The role of zero-point energy, ZPE, in Haramein's theory. It seems this radical-thinking young man, Nassim Haramein, may have completed Einstein's efforts and provided the geometric concepts and the accompanying math to finally unify the so-called separate forces. Foster Gamble. To understand how someone could take on such an audacious endeavor as unifying physics, one must understand the character of Nassim Haramein. He is an individual who does not shy away from challenges. He faces them head-on. Foster Gamble illustrates this knack for the bold and daring by recounting Nassim's love for sports and performing at the edge as an elite-level competitive skier, world-class rock-face free climber, and other hobbies over the years that many would consider extreme. Deep free diving, without a tank, racing motorcycles, and surfing monster waves in Hawaii. In a sense, Nassim took this same love for challenge and adventure to his career, of course with a reverence and respect for the foundation that had been laid by brilliant thinkers like Newton, Maxwell, Planck, and Einstein, investigating and eventually leading the theoretical development of physics. So it is fair to say that Nassim is a bit of a maverick, and as it were, such a trait is not entirely endearing within the halls of academia, where challenges to established theories are often met with derision and invectiveness. Yet arguably, a maverick is exactly what physics needs to get outside of the standard views that in almost 80 years have made little to no progress in developing a consistent understanding and explanation for the source and origin of mass, forces, and the constants of nature. In terms of recent successes, experiments for supersymmetry or dark matter have all come up null, and string theory is not directly testable. There are approximately 10,500 possible compactification solutions, each one describing a different resulting universe. There is the 2012 excitement around the detection of a signal at the Large Hadron Collider attributed to the Higgs boson, which can be interpreted as a success for the Higgs mechanism of the Standard Model, but that only accounts for 1% of the baryonic mass, which is only 5% of the total mass energy of the universe, which means that the Standard Model and Standard Cosmology can only explain about 0.05% of mass in the universe. Some might argue that is not success. Comparatively, in their latest study, The Origin of Mass and the Nature of Gravity, Haramein and his research team account for 100% of baryonic mass and all the mass energy of the universe, without positing dark energy or dark matter. Since Nassim is an autodidact and did not follow the traditional path of a physicist, not unlike many others in the history of science, Faraday, Heaviside, Feynman, etc., the physics community is prone to view him as an outsider, and in a field where appeals to authority have apparently begun to supplant open inquiry. The absence of an affiliation or a diploma from one or another university have been an often used criticism to discount his theories prima facie. Without according his work the critical review and evaluation that more traditional sources receive as a matter of course. It is tempting to see such irrelevant and specious dismissals, and often direct ad hominem attacks, as revealing an inability by the academic establishment to find fundamental errors in his models. Hence Gamble's statement, "I have seen him ridiculed and shunned by the traditional academic world, but I've just never seen him proven wrong."